Yeah, good morning. Good morning. Good morning. Listening?
Good afternoon, sir.
Yeah. So we'll start a class now. Later on, let them join later on. So I will start now the class. In a last class, we are discussing the internet work or internet working. How the internet working is a very important concept or an IP protocol for internet working, which is a main protocol which will be used today in a internet. That is an internet protocol. So where different heterogeneous networks are there, for that heterogeneous networks, how frames or information whatever is coming from heterogeneous networks will be taken, and it will be transferred from one network to the another network. That we have seen in a last class, and we have seen how the two parts of an means two services of an IP protocol will be there. One is the maintaining a unique IP addresses or a class defining for each and every system. It will adopt one internet protocol address, that is a logical address will be given to identify a system in this large network. Then the forwarding of a packet will be done using a connectionless method, that is a datagram method. How that is in a flooding, that we have already discussed, and whichever neighbors are there, through that particular neighbors the packet will be sent, and next neighbors and next neighbors, like that. And the important works in this type of a connectionless forwarding is where the redundancy of a packets will be there, and packets can fall in a loop and can be lost somewhere in a network. And then different types of routes, and maintaining a packet to move from a source to destination, whether it's moved or not. So everything, all these concepts must be checked by this particular IP protocol. And then we had gone with an IP protocol header format, and we have seen how a packet format will be there. A 32-bit row will be there, with five rows which we have taken, and another sixth row will be an optional row. And in each row, there will be a fields which is related starting from a version, and different other fields will be there. So we had discussed all that fields and what is the functioning of that particular fields, and why that particular fields has been needed. Now coming to the next topic, after the header, and I told you that for an exam, explain the header format of an IP protocol with a neat diagram. That question can be repeated question, it is asking in a exam, and you have to go through that particularly. And coming to the next concept of an IP protocol, that is a fragmentation. What is this fragmentation? That is, for example, I will tell you like this. There is a different heterogeneous networks are there. Each network will have its own type of an, a packet, and the size of an, a packet will vary from one network to the another network. So when it varies from one network to the another network, how that particular size of a packet will be moved. So when it has to move, the maximum size of a packet has to move in other network where the maximum size is less, then automatically the packet should be chopped, or the packet should be made into a parts. Best example I will tell you. Assume a ethernet just for an example I'm telling, a ethernet network is there. From there 1500 bytes packet is coming. Another one PPP network is there, protocol, peer-to-peer protocol is there. Assume that will support only 750 bytes of an packet. Now here 1500 bytes of a packet, single packet, whatever will be there, and it can't be moved in that particular network. Then what you have to do? You have to cut that, means your IP protocol has to cut that particular packet into two packets, means two parts, and it should be transferred that as a 750 bytes and 750 bytes packets in a PPP network. then it can be identified. Then what are the problems in this particular thing? Assume that it's in a network where several connections will be there and several packets will be keep on moving here and there. Then how we can come to know that the particular part of a packet is a part of this particular packet? Assume that PP network is getting other packets also from other networks also. Then how to identify these particular parts? This is a one challenge which is there. So this process we'll call it as a fragmentation. So entire fragmentation, what do you mean by fragmentation? Making a parts and identifying each and every one subparts. Once assume here Ethernet network is there, in between PP network is there, that side Ethernet network is there. Now this in PP network, the 7500 bytes packet should become two packets, and the two packets should go to Ethernet network. There, the two packets should become one packet. So how that two packets will become a one packet? How which one will be the first packet and which one will be the second packet? Just I have told an example. One packet may be of several parts, maybe 4 or 5 parts. Then how these parts will be taken into the consideration and how it will be assembled? So this is the challenge where the fragmentation works, and today class will goes on this particular topic. Now I will share that particular slide where we'll go in depth of that particular fragmentation. If anybody not hearing my voice, any problem is there, you can't see the PPT, you can interrupt me, not an issues. Now I'll share it as a window. Yes, where is this? It has been opened already. Counting. Just 1 minute. Yeah. No, I think everyone can see now. In the last class, we had discussed the packet format. As I told you that 32 bits starting from 00 to 31, 5 rows will be there, and different types of fields also will be there. We had discussed that particular thing. Coming to next, IP fragmentation and reassembly. What do you mean by this? Each network has some MTU. MTU is an means abbreviation word which you must know, maximum transmission unit. Each network will have its own maximum unit. For example, Ethernet is having 1500 bytes. FDDI means ring token network will have 4500 bytes. Now imagine here 1500 bytes and 4500 bytes. For example, FDDI single packet has to come to Ethernet network, or it has to pass via Ethernet network. Definitely it can't. So then what it has to do? It has to make into the parts of 1500, 1500, 3000, then again 1500. That means three parts it should be made. So if packets need to fit in the payload of a link layer frame, what are the solutions? Make all packet size small enough to fit all. That is, what the IP protocol has to do before sending into the other network means layer or net layer, it has to do that. It should understand that what is the MTU of that particular network. So according to that, the packet should fit, or fragment the large packets into smaller ones and reassembles them later. So that process we'll call it as a fragmentation and reassembly strategy. Fragmentation occurs in a router when it receives a datagram that it wants to forward over a network which has MTU less than datagram. That is the maximum unit, whatever is there, maximum transmission unit, whatever is there. If it is less than that particular datagram, for example, datagram is 4500 bytes. Assume Ethernet network MTU is 1500 bytes. 1500 is less than 4500 bytes. Definitely in that particular condition, a fragmentation must be needed. Then reassembly is done at the receiving host. Wherever the receiving host will be there, then that packet will be reassembled as a single packet. All the fragments carry the same identifier in the identity field. This you must know. Come back to the header field, and you can see here the identity field is there. That will play the very much important role. That is, each whatever fragmented parts will be there. How will you group that fragmented part? Means, for example, fragmented parts, whatever, all the packets will have a same identity number. That you have to keep in your mind. So that is very much important. Okay, that is done. But which will come first and which will come next? That is the next challenge which is there. Now identifying one group of packets which belongs to same packet, means parts of a packet which belongs to same packet is easy. How we can do? We can identify that with ident field. So all the packets will have a same unique number. For example, 101, assume that is made a part of three parts. Every packet will have 101, 101, 101, indicating that all three belongs to same. So that is a one thing which will be there. Now, fragments are self-contained datagrams, means it will act like an independent packets. Now you see here how the thing will be worked here. Suppose a PPP has a MTU of 532 byte packet, 20 header plus 512 payload. Assume 532 is there. Has to come to Ethernet. Again, Ethernet, nothing problem, 1500 bytes, not at all a problem is there. It will come to R2. Then R2 to R3, when it has to go, where any problem is there, you can ask me. So R2 to R3, when it has to move, R2 and R3 are in PPP network. That is a peer-to-peer protocol network, where a maximum packet size MTU is only 532. Now 532, what is this 1500 whatever is there, which will be taken and divided into the parts. Now you can see 532 and three packets it has been made, and that three packets will be sent to the R3. Again, what R3 to H8, that is the ether network is there. Again, that packets will be sent as a 512 and a 512 only. Why? Because less than MTU, 1500 less than, not a problem. Now the work of H8 is there to combine all these three 512 byte packets. So that is the one how in a real-time networks it will work. How the identification of one, which is the first one, which is the second one, which is the third one, how these things will be done. The next question will be there. Now observe carefully in this particular figure. First thing what I will tell you, assume the one big packet is there of 1400 data bytes, and the remaining 100 bytes as an header. Just for a sake I'm telling this, will assume 1500 bytes packet is there, and assume it has to be split into three 512 packets. How it will be splitted? Now observe the ident field here. Ident field X has been given, and offset value is 0, and here the field value whatever is there, means flag value whatever is there, it's 0. Now coming to here, sorry, when it make a parts, now observe carefully, the identity will be X only, and here the flag will become a 1. It means that it is fragmented packet, it is fragmented packet. Offset value will be 0, starting from 0 byte. This is a first part. Now imagine your offset value will tell you that which part it is, whether it's a fragmented or not, it will be told by this flag, and identification of the group will be done by this. Now observe the second one here. Now the second one will also, identity will have a X only, and fragmentation done, yes, the flag value is 1 here. Observe the offset value very clearly here. The offset value is 64 here. That means from 64 byte, the next it has been started. That is 0 to 6, sorry, 0 to 63 will be there in a first part, and from 64 it will start again. So again, the third one you observe here, the third part, identity is X. Now observe carefully, the flag will be 0. The flag 0 means it will indicates the last packet, means end of the fragmentation. Now you can see here the offset value here, that is equal to 128. Once the flag is 0 and the offset value is 128, means this packet will comes to know that it's the last packet based on this flag value. Now again, starting from 64 to 127 will be there in a second packet, and again from whatever 120 1 minute one yeah 128 it will starts, and remaining packets will be there here. So in this way the fragmentation will be done. Any doubt here, you can ask me. In exam you have to write these boxes and you have to explain clearly with the offset values. So I'm very clearly told here, you can see the above figure, how the means in diagrammatically how it will move from one router to other router, I have told you, and how the different fields will change here. This is a original packet, and once the fragmentation has been done, identity will be same for all the parts, and flag value will be 1, offset value will be there according to the starting byte. Here starting byte is 0, but for this packet the starting byte is 64. The last packet flag value will be 0, and where it will starts will be there. So any doubt here, you can ask me. This is called as an fragmentation and a reassembly. When it comes to the host side, means these three parts, when it comes to the host side, assume the first part will come. Just for a sake, I'll tell you. Once the first part will come, it will see the identity X, okay, and 1 is there, okay. This offset value 0, that means it's a first part, it will keep in a buffer. Assume the next packet will come, the next packet is not belongs to this parts. Assume identity will be somehow M, maybe, I'll tell you, it's not a fragmented part, 0, and offset value will be 0. Then it will think that it's not related to that, it's an independent packet, it will keep somewhere, means some other side. Assume next to this second packet will come where identity is X. Identity X already received and it's a 1, that is fragmented, and offset value is starting from 64. Then what it will do, first part is here, second part will be joined to this. Then what it will do, then it will see next packet will come. Assume this is the third packet, then it will say identity is X and the flag value is 0. That means this is a last part which has been came, and offset value is 128. So 127 is completed here, so 128 it will take, it will join that. So in this particular way it will work. So any doubts is there, you can ask me in a fragmentation. Any doubts? Any doubts? Any doubts? Hearing, students? Hearing? Hello?
Yes,
Hello?
sir.
Any doubts is there? Fragmentation you understood? So three parts is, three fields are very much important. Ident is very much important. Flag value is important. 1-bit flag value. Offset value will important. Whenever a question is asked in about a fragmentation, these three fields of IP protocol you have to mention. Now coming to the next, MTU path discovery is a good strategy to avoid fragmentation. That is, first, identifying your IP protocol, if it identifies what is the maximum transmission unit, automatically the fragmentation can be reduced. Coming to the next very important topic in IP protocol, where today the entire internet depends on this, global addresses. How a addresses, properties of a addresses, unique address will be assigned, what way the addresses will be assigned, your IP address, so that you are going to know about that. That is called as a global addresses. Now, IP addresses properties, how it will be there, globally unique, that you have to know. Once the IP address is given to one particular device in an internet, means that system will have a unique identity, means no other system will have the same IP address, that you have to keep in your mind. This is the first one. Next, what will be there in that particular IP address? The IP address will be of 32-bit. 32-bit IP address will be there. What do you mean by 32-bit? 8 fours are 32. That means 4 bytes of an information will be there always. So that 4 bytes will represent one IP address. In that, two parts will be there. One is a network and another one is a host part. One part means starting part will define the network, which network it belongs to, and the next part will tells about on a host. Network part identifies the network the host is attached to, as I told. Then host identifies a unique host on that particular network. For example, consider your USN number 1BY. 1BY. What do you mean by university? VTU university number 1BY indicates that 1 is a Bangalore region, BY is a BMSIT college. BMSIT college, which is there, means BY is a unique there. 1BY. One is a Bangalore region. In a Bangalore region, BMSIT college, right? And then 1BY, whatever the academic year is there, it will comes there, 18 or 17, 16, according to the batch. Then MCA will come, which branch? Then the number of that particular person will come. Like that, here also a parts will be there. One part will tell about on a network, the another part will tell about on a host. Ethernet addresses, even globally unique or flat, means and cannot be used for routing. Always you must keep in your address, the LAN addresses, whatever is there, will not be taken for an routing purposes. Routing will be done only within a router. That I will tell you. Note that a router is attached at least to two networks, so it must have an IP address on each port interface. That means a router which is identifying in a public network, it will have always a ports. So that IP address should be given or interfaced with both the ports, incoming port also and outgoing port also. Thus, it is more precious to think of IP addresses as belong to interfaces rather than to hosts. So the IP addresses always it will be related with the main router, and the sub networks, whatever is it, there also IP address is needed, but that IP addresses will not shown publicly. For example, if I send a packet or a information to BMSIT system, means only BMSIT will be identified by BMSIT router, which is there in a data center. Then it's a work of that router that it should circulate that to a particular system. There, the IP address again means that router should identify, not a publicly. So that you must know. Coming to the next thing. Now observe carefully here. Approximately 4 billion IP addresses of our A type. Keep in your mind, 4 billion IP addresses are there of our A type. 1 by 4 is B type, 1 by 8 is C type. Then what do you mean by this types? Class A, class B, and class C. I will tell you like this. Usually, the class A will come under the main companies who are providing internet. There, what happens? You can observe clearly. There, what happens? The first bit will be always 0. Out of 32 bits, the first bit will be always 0 here. You can observe the next coming 7 bits will be the network address, and remaining 24 bits, whatever will be there, that will be the host address. Coming to the class B, class B address will always starts with the byte 1 at the starting, byte 1 at the starting, and byte 2 will be 0, and remaining 14 bits will be network address. Totally 2 bytes. That is 14 plus 2 is 16, 2 bytes, 8 plus 8. So in that, the leftmost bits 1 and 0 will be there. Remaining 14 bits will be identified as a network address. Coming to here, another 16 bits will be of a host address. Now coming to class C, observe carefully, class C, where 1 will be there as in a single bit and 1 and 0, means always the starting 3 bits in a class C should start from 110. Are you getting 110? For example, if for class C you will tell that, sir, I will take an IP address of for example 10.10.1.0. If you ask me like that, can you take 10.10 I will tell no. Why? Because if you take a 10, whatever a 10 value is there, if you convert that to the binary, what is that? 1010. Am I right? Remaining all left side zeros should be there. So all zeros means 110 will not come. That means a number should be there where always it will start from 110. That is, observe carefully now. Observe 192 number, not less than that number. Means that is a thing which you should know, very important. But observe class A here. But 10 is okay in a class A. 10 is okay in a class A. Why? Because the first bit is 0, remaining can be a network bit. Totally 8 bits is there. That is 1010, remaining 10104 bits, remaining left 4 bits. If I put a 0, okay, then what I told 10.10.1.0, it will be a class A address. In practical also, I'm telling you, that is a class A address. Keep in your mind. So then you can observe this, the class B. Class B should start from always 1. How the starting 1, it should start always. Keep in your mind. Total 16 bits must be there. A 16 bits number must be there. Here 1 is there, you observe. So almost all it will starts from, according to me, it will starts from 171 or 172. That range it will start. So starting from 0 to that range, class A IP addresses 172 to 191 or 192, like that. The class B addresses, then from 192 again, class C addresses will be there. Where how the uniqueness is coming here, you can observe clearly. So that is a one very much important. Now I will come in practical sense. Observe carefully. When class A is the one who will provide a network to class B, means class B will be always ISP persons. You can see what is the ISP persons, means internet service providers. For example, Convergent India, which we private limited, which is our vendor who is giving a internet to BMSIT. For example, I will tell you. So this person is giving, for him he is getting a internet from somewhere else. Assume that Reliance, Bharti, or BSNL, somewhere like that. A class A vendor will be there who purchased the spectrum in a government bidding. So he will get from him this thing. Now for this particular person, series will be of 10 series or like that. He will take, means up to that. So he will take. So he means ISP providers will be a customers to him. Now for ISP providers like BMSIT, some other hotels and all will be the customers who will comes under class C, and we are the end users. We can't provide internet to other persons. So that you have to keep in your mind. Coming to the next thing. Now you will understand what is class. Class A was intended for a wide area networks. As I told you that area wise, now Bharati.com means Bharati is there, Reliance is there. So a wide network they will have throughout India, throughout Karnataka, like that. Thus there should be a very few of them will be there. Class B was intended for a modest size networks. What do you mean by modest size network? Like a campus or like one particular, according to me, like particular one small city, which you can take into the considerations. Next, class C is for large number of LANs. Class C is there for a LAN implementation. However, these classifications are not flexible, and today's IP addresses are normally classless, as we will see in the next classes. Now, come back to format here. I will tell you what is that classless IP addresses and all in later. Now you understand class A, class B, class C. Class C is very few will be there, some city area like that. it will comes a B. Then in different organizations, LANs and all, it will come C. Now, format, 4 bytes, each byte is represented by a decimal number, dot notation, that is 10.3.2.4. Observe carefully, 10.3.2.4, class A, 128 class B, sorry, 128. So from 128, if you convert 128 into the binary, it will starts with 1 and 0, means number will start with 1 and 0. You can test it out, not an problem. Next, 192. 192, when you convert it to binary, it will 3 bytes, definitely 110 will be there. So remaining bytes will change. So if you want, you can convert and you can check it out, not on a problem. So here class C addresses will start from 192.12.69.77. As an example, you can take this. This in this type, there will be a class A, class B and a class C addresses. Coming to next, IP datagram forwarding. Based on this IP addresses, how a forwarding will be done. So that you must know now. Strategy, every datagram contains a destination address, as we have already seen in IP header format, that so every packet will have an destination's address. If directly connected to the destination network, then forward to host will be done directly. If not directly connected to the destination network, then forward to some router, means which router it is connected, for that router it will send. Forwarding table maps a network number into the next hop. Then your router is held responsible to make a forwarding table. Each host has a default router, and each router maintains a forwarding table. This is very much important. Everyone, you must know. If I am connected to a network, means I am connected through router only. That means if I am sitting in a MCA lab in a system where I am working, my system is connected to a router. Within a MCA or within a college, if I want to send a packet within a network, it will send easily. Host to host, it will send. Assume that from BMSIT outside, I want to send on a packet, then my router will play the role. How it will play the role? My router will have a forwarding table, how we have discussed in a distance vector program. So it will have a forwarding table, and every system will have one particular router like that. How a forwarding table? Example, router 2, if you consider, assume here network number 1, next hop will be R1. So interface 1, so interface 0. So our next router will be 3. Means this interface 1 and interface 0 are the local LANs which is connected to R2, and R1 and R3 are the other routers. Based on this particular number, means to send, the forwarding table will be maintained in a router. Coming to the next, what is the algorithm, how it will be forwarded from that router to the other interfaces or on a other router. If network number of a destination is equal to network number of one of my interfaces, within an interface it is there, deliver a packet to the destination over that interface 0 or interface 1. Else, if network number of destination is in my forwarding table, which is there in a forwarding table, deliver a packet to the next hub, which is the next hub is there, your R1 router or R3 router, it will deliver it there. Else, deliver the packet to the default router, whichever a default router is there. For that, if you are a host, you will deliver it to the default router. If you are a router, then definitely you should deliver that to the next router. For a host with only one interface and only a default router in its forwarding table, this simplifies to, means if only default router is there. Now, network number of a destination is equal to my network number within a network. Deliver a packet directly to the destinations. Else, you send to the default router. Always this method will be there in a systems. These things will be there in a router. Above thing will be there in a router, above algorithm. But for a host, this is enough. If within my LAN connection, which is there, my system, within our router area, system is there, then you send a packet directly to that system. Else, you send to the router, router will take care of that particular thing in a coming next classes. Coming to the next thing here, subnetting. So as you know that how a subnet works will be taken into the consideration, and how class C will be taken. The network number part was designed to uniquely identify exactly one physical network. Keep in your mind, keep in your mind, that is if two LANs is there which is starting from 192 series, how to identify a particular system in that, then it will become a problem. Then how it should be identified? It will be identified using a submask or subnet mask. Now observe carefully here. However, this approach has some problems. What are that problems? A network with only two hosts has to have at least a class C network. Very simple. A network with only 256 hosts have to have at least a class B network. Thus, we will waste our valuable IP address space. For that, solution is subnetting. What do you mean by this? See, if only two system is there, class C is okay. If 256 systems is there, you have to go for a class B. But I don't want to use a class B IP address. If I use a class B IP address, for example, I will tell you, assume for us, Convergent is a one internet provider fellow, ISP internet provider fellow is there. Okay, but if he assigns or means if we want to assign as a class B person, if we want to assign IP addresses, different IP addresses to each and every systems of our college, then it will become a waste of that IP addresses space. Then what he will do, he will give to one IP address, then that will be gone within a subnetting concept. Means different LANs will be there of C class. You will take that particular sharing concept. How it will be done? Using subnetting. We will see what is a subnetting. Key idea, you see here, allocate a single network number and use it for several physical networks called subnets. Now, carefully, allocate a single network number will be allocated and use it for several physical networks. As I told you that one IP address will be given to us as an internet, then that we will share with others 200 or 300 systems. How we can share? That is called as a subnets. Several things need to be done here. What the several things you have to do? Subnets need to be physically close to each other. They should be close to each other, not like 2 kilometers, 3 kilometers away. It should be there within a building or within a campus, like that. From the internet point of view, they all look one network. That I'm telling, entire BMSIT is one network which will looks outside. A perfect situation of use subnetting is for a large campus or a corporation. That's why I'm taking a BMSID example. Configure all nodes on each subnet with a subnet mask. Underline this. That's why it's in red in color I made. Take that into the consideration. That is, configure all nodes on each subnet with a subnet mask. One LAN is there. One entire LAN will have one subnet mask. Another LAN is there. Another LAN will have another subnet mask, like that. It marks with the network part. Whatever network part is there, that will be masked always, and only host part will be taken into the consideration. Introduces the subnet number. All the nodes on the same subnet have the same subnet number and the same mask. So every node in that particular LAN will have this same subnet number and subnet mask. The IP address of a nodes ANDed with the subnet mask give the subnet number. That is, IP and subnet mask, you are going to get a subnet number. Very simple. This you must know. Usually, when you open the IP properties, whatever is there in our systems in MCA lab and all, you can see 192.168.10.1. Assume it's a IP address. Note it down. 192.168.10.1 is an IP address. Usually, what will be the subnet mask there? 255.255.255.0. Three 255s, 10 will be there. So if you do the AND operation with both IP address and the subnet mask, then you are going to get a subnet number. What do you mean by this? 192 you convert to the binary, 168 you convert to the binary, 168.10 convert to the binary 1, assume. Next, 255 you convert to the binary. What is there? All ones. Next 255 you convert. Next 255 you convert. All ones. Once. Then a 0 will be there. All zeros. Then if you do the AND operation with that, then you are going to get a subnet number. So you have to do this. If you do this, definitely you will get a lot of doubts. You can ask me in the next slide. I will show you how you have to do this. Now observe here, class B address they have taken into the consideration, how the things will be there. Now observe here, network number, host number is there. It's a class B address. Subnet mask will be 255, 255, 255.0. As I told you that 255 means ones will be there, all ones will be there here, all ones will be there, all ones like that, and 0 will be there here. 9, subnetted address will be given by increase the number of networks and reduces the number of hosts. This is a mask here, right? And class address you can use here. How subnetting you can do here? When a host wants to send a packet to a certain IP address, observe carefully. First, it does the bitwise and between its own subnet mask and destination IP address. Keep in your mind always. That is, what is destination address is there. With that, whatever the subnet mask is there, it will do the AND operation. If the result equals the subnet number of the sender, that is, whatever subnet number sender is having, same subnet number is there, then the destination host is there within that subnet, means within that network. So router is not needed here. Directly it can communicate. Else, the packet will be forwarded to another subnet, or packet will be forwarded to router. Very simple concept. Now if you want, I will tell once again. Very simple. You take this IP address, note down 192.168.10.1. You take 255.255.255.0. You take. Okay. Then if you do the AND operation there, you will get one particular address. That will be your subnet number. So each network will have its own subnet network, right? Next, so in this way the subnetting will be done. Now you see here very clearly how a subnet mask and how a subnet number will be taken into the consideration. I will tell you. Now you see this. Now according to this particular router, whatever is there here, you can see 128.96.34.15 is there. Am I right? Am I right? Now you convert this to the binary. You convert this to the binary. I will upload in YouTube channel also. You can see clearly. Convert this to binary and you convert this subnet mask to binary. Do the AND operation. You know AND operation. One and one is one. Remaining all it will be 0. That's it. So then you should get this subnet number. So for entire this whatever switch it has been connected, the subnet number will be there. So this is a router IP address and this is system IP. Like this, each and every switch subnet numbers will be there here. How a subnet numbers will be maintained? Like this. And subnet mask will be maintained. Next hop it will be decided based on that networks. So if you can do practically this particular subnetting. Subnetting is a definite question. A problem will be asked in that for 8 marks. Very clearly I am telling you. They will tell you this is the IP address and this is a subnet mask of so and so network, and this is the destination IP address, and this is the subnet mask for destination IP address. So you have to tell what is the subnet number in that. Based on a subnet number, how a forwarding table you can construct. This will be the problem to you. Definitely one problem will be there in a exam. Okay, when class reopens, I will redo this problem on board. Don't worry about that. But you try now. You can try with this slide. Very clearly, the slide is telling how you can do and all. And if you have listened carefully, what I have told how to do the AND operation, you can do clearly. Not an issues there. Now this is subnetting. Now very one important problematic question which will be asked in this particular unit. Well, for a next class, we'll go. This is the algorithm for a subnetting. You can study this particular algorithm. Very simple. D is equal to destination IP address. For each entry less than a subnet number, subnet mask or an X stop. D1 is equal to, sorry, D1, observe how D1 is calculating. Subnet mask into whatever IP address, means under, single under by, means this is a bitwise operator. So we will be used with. If D1 is equal to subnet number, within the network, within that LAN, you send the packet, means broadcast that. Else you send to router. That's very simple. So AND operation doing is very much important. You have to do carefully. This ends your subnet. Classless addressing we will do in a next class. Okay. I'll back here. I'll stop sharing. Yeah. Close this. Yeah. Now coming back here. See, so today what I told is one of the important lesson both for a career in many companies, technical rounds and all. They will ask questions on class A, class B, how a subnet mask will be identified. So as a network engineer, how will you get a subnet number? So these technical round questions asked for your seniors many times in many companies, Maventech, Cerner, like this. Many companies repeatedly they ask these questions. Also, for your career sake, also this subnetting fragmentation is very much important. Why? Because for entire network, this is like a backbone. Okay, implementation of a network when you want to do as a network engineers, this is very much important. Okay, yeah, this will be uploaded in a department YouTube channel also, which you can see. Okay, any doubts is there? You can ask me now. Any doubt?
Sir, I
Yeah.
have doubts, sir. Sir, I have doubts. Sir, like IP address become same. What will happen, sir?
IP address
Become same, sir. IP address is same, sir. What will happen?
same ಆಗಕ್ ಚಾನ್ಸೇ ಇಲ್ಲ. Who is speaking? Can I know?
Ashok.
ಅಶೋಕ್, IP ಅಡ್ರೆಸ್ ಸೇಮ್ ಆಗ್ಲಿಕ್ಕೆ ಚಾನ್ಸೇ ಇಲ್ಲ. IP ಅಡ್ರೆಸ್ ಯಾವ ರೀತಿ ಇರುತ್ತೆ? ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ IP ಅಡ್ರೆಸ್ ಸೇಮ್ ನೀನ್ ಹೇಳಿದ್ದು ಒಂದು ಲೆಕ್ಕದಲ್ಲಿ ಯಾವ ರೀತಿ ಇರುತ್ತೆ ಅಂದ್ರೆ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಐ ವಿಲ್ ಟೆಲ್ ಯು, ಇಲ್ಲೊಂದು ಲ್ಯಾನ್ ಇರುತ್ತೆ, ಅದಕ್ಕೊಂದು ಸಬ್ನೆಟ್ ಮಾಸ್ಕ್ ಇರುತ್ತೆ, ಇಲ್ಲೊಂದು ಲ್ಯಾನ್ ಇರುತ್ತೆ, ಅದಕ್ಕೊಂದು ಸಬ್ನೆಟ್ ಮಾಸ್ಕ್ ಇರುತ್ತೆ. ಅಬ್ಸರ್ವ್ ಮಾಡ್ಕೋ, ಸಬ್ನೆಟ್ ನಂಬರ್ಸ್ ಚೇಂಜ್ ಇರುತ್ತೆ. ಅರ್ಥ ಆಗ್ತದ್ಯಾ ನಾನು ಹೇಳ್ತಾ ಇರೋದು ನಿನಗೆ? ನಿನಗೆ ವರ್ಲ್ಡ್ ಪಬ್ಲಿಕ್ IP ಇಂಟರ್ನೆಟ್ ಅಲ್ಲಿ ಪ್ರತಿಯೊಂದು ಇಂಟರ್ನೆಟ್ ಅಡ್ರೆಸ್ ಯೂನಿಕ್ ಆಗಿರ್ಬೇಕು, ಇದು ಮಸ್ಟ್. ಹಂಗನ್ಬಿಟ್ಟು ಈಚ್ ಅಂಡ್ ಎವರಿ ಸಿಸ್ಟಮ್ಗೆ ನಾವು IP ಅಡ್ರೆಸ್ ಕೊಡ್ತೀವಿ ಅಂದ್ರೆ IP ಅಡ್ರೆಸ್ ವೇಸ್ಟ್ ಆಗತ್ತೆ. ಅದಕ್ಕೆ ಏನ್ ಮಾಡ್ತಾರೆ ISP ಪ್ರೊವೈಡರ್ಸು, ನಿಂಗೆ ಕ್ಲಿಯರ್ ಕಟ್ ಆಗಿ ಹೇಳ್ತೀನಿ, ಅದಕ್ಕೆ ಏನ್ ಮಾಡ್ತಾರೆ ISP ಪ್ರೊವೈಡರ್ಸು ಒಂದು ರೂಟರ್ ಇಡ್ತಾರೆ. ಆ ರೂಟರ್ ಇಟ್ಬಿಟ್ಟು ಆ ರೂಟರ್ಗೆ ಒಂದು IP ಅಡ್ರೆಸ್ ನ ಫಿಕ್ಸ್ ಮಾಡ್ಬಿಡ್ತಾರೆ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಅಸ್ಯೂಮ್ 172 ಒಂದು IP ಅಡ್ರೆಸ್ ಏನೋ ಒಂದು ಕೊಡ್ತಾರೆ, 172.10 ಡಾಟ್ ಸಮಥಿಂಗ್ ಒಂದು ಕೊಡ್ತಾರೆ. ಅದು ಫಿಕ್ಸ್ ಆ IP ಅಡ್ರೆಸ್. ಆ IP ಅಡ್ರೆಸ್ಗೆ ಆ ರೂಟರ್ಗೆ ಇಂಟರ್ನೆಟ್ ಬರಕ್ ಸ್ಟಾರ್ಟ್ ಆದಾಗ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಲ್ಯಾನ್ಸ್ ಬರಬೇಕು. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಈಗ MCA ಲ್ಯಾನ್ ನಾವೇನ್ ಮಾಡ್ಕೊಂಡಿದೀವಿ, 192.168.10.1 ಅಂತ ಸೀರೀಸ್ ಮಾಡ್ಕೊಂಡಿದೀವಿ ಅನ್ಕೋ. ಮ್ಯಾಕ್ಸಿಮಮ್ 255 ಸಿಸ್ಟಮ್ಸ್ ನ ಒಂದು ನೆಟ್ವರ್ಕ್ ಅಲ್ಲಿ ಹಾಕ್ಬೋದು ಕ್ಲಾಸ್ ಸಿ ನಲ್ಲಿ. ಸೊ ನಮ್ಮ ಲ್ಯಾಬ್ ಅಲ್ಲಿ 30 ಸಿಸ್ಟಮ್ಸ್ ಇದೆ, 60 ಸಿಸ್ಟಮ್ಸ್ ಇದೆ. ಈ 60 ಸಿಸ್ಟಮ್ಸ್ 192 ಸೀರೀಸ್ ಅಲ್ಲಿ ಹಾಕೊಂಡಿರ್ತೀವಿ. ಅದ್ರಲ್ಲಿ ಏನ್ ಮಾಡ್ತೀವಿ ನಾವು, ಅಬ್ಸರ್ವ್ ಕೇರ್ಫುಲಿ, ಅದ್ರಲ್ಲಿ ಏನ್ ಮಾಡ್ತೀವಿ ನಾವು, ಒಂದು ಸಿಸ್ಟಮ್ ನ ಸರ್ವರ್ ಅಂತ ಇಟ್ಕೊಂಡ್ಬಿಟ್ಟು ಆ ಬರ್ತಿರೋ ಇಂಟರ್ನೆಟ್ ನ ಅದಕ್ಕೆ ಕನೆಕ್ಟ್ ಮಾಡ್ತೀವಿ. ಯಾವುದು 192.168.0.1 ಇದು ಒಂದ್ ಸಿಸ್ಟಮ್. ಅದಕ್ಕೆ ಕನೆಕ್ಟ್ ಮಾಡಿ ಮಿಕ್ಕಿದ ಸಿಸ್ಟಮ್ಸ್ಗೆಲ್ಲ ಇಂಟರ್ನೆಟ್ ಕೊಡ್ತೀವಿ. ಯಾವ ರೀತಿ ಕೊಡ್ತೀವಿ, ಈ 192 ಸೀರೀಸ್ ಏನಿದೆ ಅಲ್ಲಿ ನಾವು ಮಾಡ್ಬೇಕಾದ್ರೆ ಮೀನ್ಸ್ IP ಪ್ರೋಟೋಕಾಲ್ ಪ್ರಾಪರ್ಟೀಸ್ ನ ಸೆಟ್ ಮಾಡ್ಬೇಕಾದ್ರೆ ಗೇಟ್ವೇ 192.168.0.1 ಅಂತ ಕೊಟ್ಟಿರ್ತೀವಿ. ಆಮೇಲೆ ಸಬ್ನೆಟ್ ಮಾಸ್ಕ್ 255.255.255.0 ಅಂತ ಕೊಟ್ಟಿರ್ತೀವಿ. ಅಂದ್ರೆ ಈ ಗೇಟ್ವೇ IP ಅಡ್ರೆಸ್ ಜೊತೆ ಈ ಸಬ್ನೆಟ್ ಮಾಸ್ಕ್ ಯಾವಾಗ್ಲೂ ಅಂಡ್ ಆಪರೇಷನ್ ಮಾಡಿದಾಗ ಒಂದು ಸಬ್ನೆಟ್ ನಂಬರ್ ಬರುತ್ತೆ. ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ ಶೋಕ್? ಹಲೋ, ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ? ಈಗ ನಾನು ಹೇಳಿದ ಅರ್ಥ ಆಯ್ತಾ ನಿಮಗೆ? ಈಗ ನಮ್ಮ ಲ್ಯಾನ್ ಅಲ್ಲಿ ನಾವು ಒಂದ್ ಸಿಸ್ಟಮ್ ನ ಸರ್ವರ್ ಅಂತ ಮಾಡಿರ್ತೀವಪ್ಪ, ಅದು ಡಿಫಾಲ್ಟ್ ಗೇಟ್ವೇ 192.168.0.1 ಅಂತ ಇಟ್ಕೋ. ಸಬ್ನೆಟ್ ಮಾಸ್ಕ್ ಏನ್ ಮಾಡ್ತೀನಿ 255.255.255.0 ಅಂತ ಕೊಟ್ಟಿರ್ತೀನಿ. ಇವೆರಡ್ರ ಜೊತೆ ಅಂಡ್ ಆಪರೇಷನ್ ಮಾಡಿದ್ರೆ ಈಚ್ ಬೈನರಿ ಕನ್ವರ್ಟ್ ಮಾಡ್ಬಿಟ್ಟು ಅಂಡ್ ಆಪರೇಷನ್ ಮಾಡಿದ್ರೆ ಒಂದು ವ್ಯಾಲ್ಯೂ ಬರುತ್ತೆ. ಅದನ್ನ ಮತ್ತೆ ನಂಬರ್ ಆಗಿ ಮಾಡಿದ್ರೆ ಅದು ನಮ್ ಸಬ್ನೆಟ್ ನಂಬರ್. ಅಂದ್ರೆ ಆ ನೆಟ್ವರ್ಕ್ ಗೆ ಸಬ್ನೆಟ್ ನಂಬರ್ ಅದು. ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ? ಹಂಗೆ ಬೇರೆ ಲ್ಯಾನ್ ಅಲ್ಲಿ ಬೇರೆದಿರುತ್ತೆ. ಸೊ ಅಲ್ಲಿಗೆ ಒಳಗಡೆ ಇರೋ ಸಿಸ್ಟಮ್ಸ್ ಆಚೆ ಕಾಣಲ್ಲ. ಇಲ್ಲಿ ಕಾಣಿಸೋದೇನು ಗೇಟ್ವೇ ಒಂದೇ ಕಾಣಿಸೋದು 192.168.0.1 ಅನ್ನೋ ಸಿಸ್ಟಮ್ ಮಾತ್ರ MCA ಸಿಸ್ಟಮ್ ಆಚೆ ಕಾಣಿಸ್ತಾ ಇರುತ್ತೆ ರೂಟರ್ಗೆ. ಇನ್ನು ಬೇರೆ ಯಾವ ಸಿಸ್ಟಮ್ಸ್ ಕಾಣಲ್ಲ. ಆ ರೀತಿ ವರ್ಕ್ ಆಗ್ತಾ ಇರುತ್ತೆ. ಗಾಟ್ ಇಟ್? ಓಕೆ ಮಾ, ಓಕೆ. ಇನ್ಯಾರಿಗಾದ್ರೂ ಡೌಟ್ ಇದೆಯಾ? ಇನ್ಯಾರಿಗಾದ್ರೂ ಡೌಟ್ ಇದೆಯಾ? ಎನಿಬಡಿ? Okay, can we end the session? Can we end the session? Hello? ಮಿಕ್ದವ್ರು ಯಾರು ಮಾತಾಡ್ತಿಲ್ಲ.
Yes, sir.
Okay, ma. Thank you very much. Bye.
Yes. Yes. Thank you.